All right. So, good evening, everyone, again to this brand new lecture of the chapter probability. So, today we are starting this next chapter probability, and it is highly important from the perspective of whether you are giving your boards exams or whether you are giving your JEE Mains or if you are participating in the Olympiads also. So, you can expect from this in the JEE Mains one or two questions you can expect. Two is the maximum extreme case, right? However, one question will definitely come, and that question can be from the any of the topic that we will be studying in this chapter. Okay, so we will be discussing from the basics to the detail, right? First, we will understand that what are the different types of events, some basic terminologies, and and a lot of different things. And after that, we are going to start the actual some theorems actually. Okay, that is like Bayes theorem or it is a total probability theorem. Okay, so all those topics will be studied and some part of statistics as well. All right, so stay tuned for this lecture. Now we're starting with the, so in today's class we are going to discuss about the random experiment and sample space. So this session will be going to be covering the basics portion of this chapter. Okay, and of course this will be the first session, so we are covering only the basics. So let's start. So today in the class we will be discussing random experiment and sample space, that what is exactly these terminologies means. Then we will discuss events and types of events, and after that we will be discussing classical definition of probabilities. Okay, so let's start with the first topic. The first topic is random experiment. So what is it? So we say that if an experiment is happening, okay, experiment is happening in which we are saying ki the outcome of one does not affect the others. Okay, so it is written here, it is an experiment which results in an outcome. Okay, an outcome will come, but which is one of the various possible outcomes that are known beforehand. Basically, you will be known some of the outcomes, but you can say that if you are having coins, let's say, okay, you are having coins, so you can say there are two possibilities for the coins if you toss, right? Either head or tail. So you know beforehand, right? You know beforehand that what can be the possible outcomes. Okay, similarly for throwing an throwing an this cube, this dice, sorry. Okay, you can see either you can get 1 2 3 4 5 6 like that you can get, but remember one thing, these all are not related to each other. Okay, so these are what random experiments. Okay, so here's a note point given, a possible result of a random experiment is called as outcome. Okay, next, now I'm just asking you that a simple question. This question says that ki find the, or we can say write the sample space of the experiment A, experiment in which it is said that a coin is tossed. So you know that if a coin is tossed, how many possibilities you can get? How many possibilities? And a die is thrown also, right? So two things are given here. For a coin there will be two possibilities, and for the dice there will be six possibilities. So how do we write the sample space? Sample space is what? Again, the sample space is nothing but you are saying the total possible outcome you are getting from an experiment. Yes, h comma t. Okay, not h comma t actually. Read the question carefully. Two things are happening here. First, the coin is tossed, and second, the die is also thrown. Okay, so we will understand how to write the possible outcomes. See carefully. If you see, either we can say that if head is coming on the coin, along with that on the dice 1 2 3 4 5 6 can come. So total possibilities like this, you are getting six possibilities from here. Similarly, you can say if a tail is occurring on the coin, then again the six possibilities can happen on the dice. So again the six possibilities. So total, how many possibilities you will be getting? Total 12. So total possible outcome of a random experiment is called as sample space. So you can see H1, H2, H3, H4, H5 and so on like T6. So this is what our sample space. Now this can also be written with the help of the what? with the help of the combination formulas that you have studied already in the permutation and combination chapter. Let's see how we will write that. Just a second. You can see there is a coin, okay, and then dice. First of all, tell me that coins have two possibilities, right? Coins have two possibilities, either tail will come or either head will come. So if two possibilities for coin is there and only one coin is there, so you can say ki out of the two possibilities one can happen at a time, right? So 2C1. Similarly, for the dice, out of the six possibilities, total six possibilities are can happen, 1 2 3 4 5 6, any number can happen, and at a time you are saying that only one number will be coming. So total probability will be not, sorry, total we can say the sample space, or we can say total number of elements in the sample space will be equal to what? 2C1 to 6C1, that will give you nothing but 12 again. Okay, so either with the help of combination formula or either with the help of basics we can go, we can find. So we'll understand later also. Here the note point is given that each element of a sample space or each outcome of an experiment is called sample point. Yeah, so these actually, this H1, this H2, this H3, these are called as sample point. Getting this point? Okay, this is called as sample point, each element. Yes, they tell me. This, how this came, you're asking? 2C1 and okay, so I'm saying that uh, for a coin two possibilities can happen na, head or tail. Okay, but at a time a coin will show only one possibility, so out of the two possibilities you are selecting one. Okay, so 2C1 into, similarly for the dice six possibilities are there, but at a time if you roll a dice at one time only one number can come, right? So that means we are selecting out of six, it can come any of them. Okay, so 6C1 means you are selecting any of them, 6C1. All right, so when you multiply them it will give you the answer. And of course if you are saying that why we are multiplying, then you can see these events are happening one after another, and is given. Okay, if or is given you have to add them, but we will understand later that whether how to identify that also. Okay, yeah, let's go to the next part. Yes. Okay, as I said, the random experiment is nothing but, you can say, an experiment which consists of some outcomes, okay, which may be known beforehand. Okay, which may be known beforehand means various possible outcomes will be there that are known beforehand. Suppose tossing a coin, you know that already ki two outcomes can come, but these are not related to each other. Okay, if head is coming, definitely the possibility of tail is gone. If tail is coming, definitely the possibility of head is gone. Are you getting this point? Similarly in the dice also. Okay, no, that's what I'm saying. You can guess that some of the outcomes you can guess, right? Suppose that if I'm saying that 16 coins have been tossed. Okay, so for that you must have to know about that how the how what are the various possible outcomes. Okay, but how will you know that? That's okay, that for a coin only two possible things can happen, either it is head or either it is tail. But the thing is that ki uh, uh, we will be saying that both of them are not related to each other. So random experiment doesn't mean only ki, it means that the outcomes are not known. Okay, random experiment, it does mean that the outcomes whatever is coming, they are not related to each other. Getting this point now? Okay, so yes, next point is sample space, set of all possible outcomes of a random experiment, as I already told you. So this is also a random experiment, rolling a dice or throwing a dice, and total possibilities can happen 1 2 3 4 5 6, and this will be written as sample space S. So S is the representation, and this curly braces actually uh, is, you know that already, the representation of set. So and these 1 comma 2 comma, this will be called as elements or sample point. Okay, sample space is done. Then we are, then I'm asking you the question. This question is saying, write the sample space of the experiment. A coin is tossed. If it shows head, a coin is tossed again, else die is thrown. So can anyone tell me what are the total number of elements in this sample space you will be getting? 8. Any other student? Yeah. So let's solve this. Of course, 8 will be the answer. You can see they are saying a coin is tossed. So coin, you know that already. Coin can have two possibilities. Either head will come or either tail will come. And they are saying again, ki if it shows head, uh, a coin is tossed. If it shows head, coin is tossed again. Yeah. So if it shows head, then it will be tossed again. Else die is thrown. So can you say that if tail is coming, that means now the dice is thrown, right? And if the head is coming, that means coin again tossed, coin tossed again, right? So how to write the possibilities? How to write the possibilities? You said that ki first already head has been came. Okay, now two possibilities can again come by tossing the coin again. That is, one is h, that is head, and then tail. So I can say that total possible outcomes is hh and ht. Similarly here, you know that when a die is thrown, what are the possible outcomes? 1 2 3 4 5 6. So how will you write in associated with the tail? Because on the coin the tail is also coming na. After that only we are throwing a dice. So we'll say that one possibility is t1, second is t2, t3 means tail, and then on the dice is 1, then tail on the dice is 2, and so on up to t6. So total number of elements here are 6, total number of elements here are 2. So you can say total number of elements in the sample space will be 8. Okay, same thing you can see here in the diagram also. You can see if the coin is tossed and head came, if head came, it means two possibilities first of all will happen. That means you have to toss the coin again. So head can come or head tail can come. The next possibility is that when tail came, so when tail is came, you have to roll a dice, and on the dice 1 2 3 4 5 6 are possibilities. So along with the t1, then t2, t3, this can happen. Okay, so sample space are given, total number of elements you will be writing like this, number of elements of S is equal to 8. This is the answer. Okay. Let's go to the next part. Sample space is done. One more question next. Yeah, tell me. No, those will be subset na, then those will be subset. It is ordered pair, like you are saying, like ht comma hs, like this you are saying. Acha, bracket, this one, open bracket. Huh. Okay. Acha, comma one. Okay, then but how will you associate the yeah, you are correct, I got it. Huh, I got it. Huh. Yeah. Yeah, tell me. Hmm. Open brackets. Huh. They will represent apps. That can ordered pair you can say, but you cannot say that only if we are representing anything in a open bracket, then they will surely represent the coordinate. It is not necessary like that. No, they can be ordered pair also. You have studied in the sets. No, in the sets you have studied no ordered pair. Remember? Okay, so that is also the representation, but this will be called as ordered pair, not coordinate actually. Okay, yeah. So here also the set theory is associated. Now, this bracket, these curly braces are showing what? That the sample space S is basically a set which is having these elements. And if you are having doubt, ki, sir, how this H T is written, why not we are writing H comma T? Because because first you have thrown a coin, and then again if head is coming, then again you have thrown the coin. So it is like two coins have been tossed. So if two coins have been tossed, then the output of two coins will be written at a time. So that's why HT and HH. Now it is clear.
Can you please repeat the last statement?
I'm saying if a coin is tossed one time, let's say, because in the question it is already said ki if head is coming, then coin is tossed again. So if the coin is tossed again, it means that again you will have two possibilities, H and T. So it means that the coin is tossed two times now. If the coin is tossed two times, that means you have to write the output also. The both associated means associated to the both. Basically, one HH and the second is HT. You cannot write separately. Okay. Similarly, similarly, the next thing also ki either you are saying ki a coin is tossed twice. Okay, a coin is tossed twice. It means that same coin is there and you have tossing. You are tossing this two times, or you are saying two coins are tossed. Two coins are tossed. Okay, these are same thing. These two are same thing. Clear now? Hmm. In the dice, you are saying, huh, that's correct. But these are basically this is not the you can say ki if the numbers are there. So basically you can see na ki in the dice there are only numbers. Okay, in the dice there are only numbers. So you are writing them in that format, and here you are having letters. So if same letter is coming, let's suppose same letter is coming, it is representing the same output. But what you are saying, what is the meaning of this? H comma H are the separate outcomes of two different coins. You cannot say that this is the HH is the outcome. HH is the outcome of a coin if it has been tossed twice. Okay, if the comma is there between in between. So in order to associate that, so you can say that that is a way of representation, right? That is simply you can understand like this ki this is the way of representation in the uh, number for the dice, that is in the ordered pair, and here we are writing in the like only pair without comma. Okay, yeah. Okay. Next question is find the number of elements in the sample space of the experiment rolling a pair of dice. So the last question we already done. Huh? Okay. So find the number of elements in the sample space of the experiment rolling a pair of dice. Pair of dice means you are tossing, you are rolling two dice. Two dice has been rolled. Two dice are rolled. So of course it is a simple one. You already know it. Uh, you know that on a single die, what are the possibilities? 1, 2, 3, 4, 5, 6. Similarly, on the second die, let's say D2 I'm writing, and D1 is the first die. So again you can say 1, 2, 3, 4, 5, 6. If you want to understand in the easy manner, you can say ki 1 can be paired with 1, 1 can be paired with 2, 1 can be paired with 3, or and so on. Similarly, 2 will be paired with 1, na? 2 will be paired with 2. So let me represent this with a different color. Similarly, 2 will be represented with 1, then 2, then 3, and then 4, and so on. Okay, so if you write that, you will be getting like this. Two dice are like this. We can keep one of the die fixed, that is a, let's say on the second die we are saying that the number 1 is fixed, and then the first die is changing its numbers 1 2 3 4 5 6, and similarly it's go on like this. So you will be getting total 1 comma 1 1 comma 2 1 comma 3 1 comma 4 5 comma 5 and so on like that. 6 comma 6 last element. So total number of elements will be 6 rows and 6 columns. So 6 into 6 36. Okay, is that clear? All right, so I wanted to explain one thing here. Just give me a moment. It's a just a moment. Yes. So as you saw कि in rolling a pair of dice you are getting the possibilities 1 comma 1 1 comma 2 1 comma 3 1 comma 4 1 comma 5 1 comma 6. Okay, I am writing this to explain you something, so you can also write if you want. 2 comma 4 2 comma 5 2 comma 6 3 comma 1 3 comma 3 2 3 comma 3 3 comma 4 3 comma 5 and then 6. Similarly 4, okay, then 4 comma 2 also. So write all of these pairs. Sometimes for like easy questions this can be used directly, or if you remember this also. Do let me know if I have missed something, right? 6 comma 1 6 comma 2 6 comma 3 6 comma 4 then 5 and then 6. So the thing that I want to tell here is these pairs in which we are having the same numbers, these pairs in which we are having the same numbers on both the dice are called as doublets. This one, these are called as doublets. Okay, and you can see how many doublets you will be getting here. 6. Okay, so 6 doublets you are getting in total. We can say number is 6 here. So if out of 30 total sample space, you already know number of sample space means elements of the number of elements of the sample space will be 36. Out of 36, if you remove the 6, you will get 30. So out of 30, you can say out of 30 you can say कि the elements which are below the doublets, elements which are below the doublets are total 15 elements. Similarly, elements which are above the doublets are in total again 15 elements. But what is the purpose to explain this? The purpose is that in some future, in near future, they can ask you a question like this: कि find the probability of getting, or we can say, let's say they are saying that 2 dice have been rolled. Find the probability of getting uh, the number on the first die greater than the second number. Okay, did you understood this part? They are asking you that find the probability of getting number on the first die greater than the number on the second dice. So you will be writing in the ordered pair all the possible outcomes, right? So you can see in the denominator, in that means the below the doublet, all the first die, all the number on the first die is greater than the second dice. So simply, what should be the answer then? Total possible outcomes are 36. 15 are the elements which you know that is our favorable outcomes. So total, you can easily answer this. Similarly, they can also ask you the other way, that what is the probability or possibility that on the first die the number will be lesser than the second die. Okay. Similar is the case with the triplet. Can anyone give me the answer? Sorry, not triplet. Actually, triplet is a term. Okay. So suppose if three dice have been rolled, if three dice have been rolled, then can anyone tell me what are the number of triplets you'll be getting? Triplets means triple pair, means like 1 comma 1 2 comma 2, like that. Anyone can tell me what are the number of triplets you'll be getting? Exactly. Again, you'll be getting 6 only. So this is a thing in this dice problem, that no matter how many dice you are rolling, if they're asking the same pairs, okay, like in the two when the two dice are rolled, doublets will be coming. Three dice are rolled, triplets will be coming. Similarly, quadruplets, like that. So they all will be 6. Okay. So but that will depend on the question to question what they are asking. We will discuss them later. Let's go on to the next part. Now we are starting with the basic part, event. What is an event? It is an outcome or defined collection of outcomes of a random experiment. Means whatever the random experiment you have performed, for that, whatever the outcome is coming, the collection of all those outcomes is called an event, and it will be always be a subset of that sample space. So sample space, you already know the total possible outcomes. Total possible outcomes are sample space, which can be represented by universal set S, and the set A is a smaller portion of that universal set, which we can easily say that it is a subset of universal set or subset of sample space. Okay. Next part. Okay, there is example given. For this, there is example given. You can see. Let's say a coin is tossed twice. So a coin is tossed twice. How many total possible outcomes you can get? First of all, sample space I am writing here. So you will be getting either HH, HT. Means on the first coin, if you are fixing head, so on the second coin, head and tail can come. Then the third possibility is that if on the first coin, if tail is fixed, then on the second coin, head and tail can come. So 4 possibilities are there. So let's say the question is like this: ki event A is getting exactly 2 tails. So you can see in this sample space, how many elements are there in which you are seeing 2 tails exactly. So 2 tails means only one element. So A is having only one element. So you can write like this: A is equal to curly braces of TT. Similarly, it is asking getting at least one head. Acha, this is also, you have to understand here, at least means minimum one head should be there. More than that, 2 head can also occur. Minimum one head should be there, 2 head can also occur. And when it is asking you at most, when it is asking you at most, they will say that, let's say at most one head it is saying. So at most one head means maximum one head can come. Maximum one head can come. Lesser than that, 0 head is also possible. You know that 0 head, in this case, only one possibility will be there in which both the tails will come. Is it clear, everyone? This point is clear? So at least and at most, these are terms which will be used numerous times. So do not confuse in them. It is very easy portion. Then last is event C. Event C is saying that getting more than 2 tails. More than, so you already know, more than 2 tails is not possible in tossing of 2 coins. So it means that it will have no elements. Okay, it will have no elements. So we can say set C will be defined as 5. See, C is defined for this set. Okay, and when you will be writing number of element of C, that will be written as 0. Okay, clearly understand the difference. Alright, so you can see that when one coin is tossed, 2 possibilities are there. When 2 coins are tossed, 4 possibilities are there. 3 coins are tossed, 8 possibilities will be there. Similarly, it will go on. So you can express this in the formula, that is total possible outcomes you can write in the format of 2 to the power n if the sample space has n elements. Okay. Yeah, this is only for coin, of course. This is only for coin. Okay, only for coin. Yes, write that here also. Next type of event is, okay, now we'll be understand the next types of events. Impossible and sure event. What is the impossible event? As the name suggests, impossible event means that is not possible. Okay, suppose that I'm saying you are having 52 you are having the 52 playing cards, and you are saying that choosing four face cards of spade, you already know that only three face cards are there in each suite. Okay, we will be discussing later also ki what are the suites is actually nothing but the set of 13 cards of each shape. Okay, so in each shape you can see only three face cards are there. So how it is possible to extract or choose four face cards? So of course it is clearly mentioning the impossible event. So if it is impossible event, then its probability will be, you can say, 0. Okay, and the set will be 5. For this set will be 5, so that's why they're saying that impossible event means the empty set 5 is called as impossible event. The simple thing. Okay, next, sure event. Now we will discuss sure event. So for the sure event, what we are saying, ki whatever the number of elements in an event you are getting, if they are becoming equal to the sample space. Okay, whatever the number of elements in an event you are getting, if they are becoming equal to the total number of sample space, then this event will be called as sure event. Okay, suppose that it is said ki throwing a whole number less than or equal to 6 in a die. So you know that if you are throwing a die and your event says that ki you have to get a whole number which is less than or equal to 6, means 6 is possible, 5 is possible, 4 is possible, 3 is possible, 2 is possible, and 1 is possible. Right? 0 is not possible here. Right? So in the event also you are getting 6 elements. In that event is also you are getting 6 elements. The number of elements of event is also 6. And the number of elements of sample space means total possible outcomes are also 6. So when the number of elements of event will become number of elements of sample space, then this will be called as sure event. Is that clear? These are basic terminologies which can confuse you at any point of time. So that's why be alert. Next question, next type of event. Simple event. Simple event, as the name suggests, it will have only, you can say, single, or you can say one sample point in the sample space. Okay, one sample point only. So you can say out of the total sample space, if you are getting only one sample point in the event, then this will be called a simple event. Suppose that example is given, getting a head followed by a tail. Getting a head followed by a tail means first head will be coming and then tail will be coming. So you can see out of the four sample space, out of the four elements in the sample space, only one possibility is there. Okay, only one possibility is there. So means we can say our event is having only one element. So this will be called as simple event or elementary event. Okay, these are very basic terms. Compound event. Next is compound event. When you say an event, if an event is having more than one sample point, actually more than one sample point of a sample space, and then it will be called as compound event. You can see getting at least one king in drawing of two cards. Getting at least one king in drawing of two cards one by one out of 26 red playing cards. Okay, let me brief you about the cards problems. So there are total 52 cards are there. Okay, and there are four suites. Each suite consists of 13 cards. Each suite consists of one suite consists of 13 cards. Okay, so you know that this is one suite, this is one suite, and this is one suite. All of these suite are having different shape. All of the suites are having different shape, and those different shapes are nothing but, let me write here, one second. Yeah, so all of the different suites, this color is not working. You can see कि one can be in the shape of heart. Okay, second you can say in the shape of diamond. These both are red. These both are red. Then the third one is in the shape of club. This is called as club. Okay, and then fourth is nothing but our spade. Spade, like this. Okay, and these both are black. So you can see 13 cards. So of course this is 13, this is 13, this is 13, and these are also 13 cards. Total 26 cards are red. So 26 red cards and 26 black cards. That's it. That is the basic of the cards you must know. So now see this carefully. The question is saying getting at least one king in drawing of two cards one by one out of 26 red playing cards. You know that 26 total red playing cards are there, and they are saying getting at least one king. At least one king means minimum one king can possible, minimum one king, and maximum how many kings you can get from the only red cards? Two kings. So therefore two kings are also possible and one kings are also possible. Okay, what does it mean KD and KH? KD means king of diamond. KD means king of diamond. So I'm writing here. Okay, you don't confuse that. King of diamond. And KH means king of heart. King of heart. And KN, sorry, KN is saying that not a king. KN is saying that not a king. Right? So this is the, so now you can see the possibilities. What are the possibilities? Different possibilities. KD and KH means king of diamond, king of heart, king of heart, king of diamond. Two kings, two kings can also come if you are choosing two cards. Then king of heart and not a king, not a king and king of heart. Then king of diamond, not a king, then not a king and king of diamond. Basically you are saying that all the possibilities, all the possibilities in which one king is there. Right? So this is the, you can say, uh, how many elements you are getting? 1 2 3 4 5 6. To total number of elements of set A, or we can say this event A, is 6. 6 na, so this will be called as compound event. More than one sample point, compound event. Right? Let's go to the next part. Algebra of events. Now we'll understand complementary event. Complementary means opposite, or you can say total minus that particular event. So suppose that complement of an event set A, event A you have to write with respect to the sample space. Then this will be simply nothing but will be represented by A complement or A superscript C. And how do we write the elements? We have to subtract all the elements which are subtract all the elements from the sorry, which we have to subtract all the elements of set A from the sample space. Okay, so it is saying that uh, with respect to sample space is the set of all elements in S which are not in A. The same thing, right? So you can see event A, if it is defined like number showing should be greater than or equal to 5. Okay, greater than or equal to 5. So how many possibilities are there? Only 5 and 6 can come. However, in the sample space you are saying, in the sample space you are saying that 6 possibilities are there. So then if I ask to write the complement of A, or yeah, complement of A or complementary event, so A of C will be nothing but S minus A. Okay, this set minus sample space set minus sample space, sorry, sample space set minus event set A. So this is having 1 2 3 4 5 6, and this is having only 5 and 6. So you can see remaining element will be 1 2 3 4 only. Is it clear? Yes, Arun, tell me.
Sir, can you please say the meaning of this Algebra of events.
Algebra means we will be discussing uh, the addition, subtraction, like that. Okay, that is nothing. That is the same thing. So we will associate the set theory here, actually, that what is the union, what is the intersection of two sets in the probabilities. Sorry, in the two events actually, right? So because we are saying here events, so we will be discussing the algebra of events. Earlier in the set theory, you have discussed the algebra of sets. Okay.
Yes, sir.
Okay. Next, A or B. As I said, it has came here. A or B. So these A and B are event. A or B means you are saying either A union B, that represents the occurrence of either A or B. Either A or B means when you represent it with the help of Venn diagram, this is the Venn diagram. This is the total possibility that will be covering in this page. Okay. Next part. Uh, it's a simple question I have asked here. In throwing a die, event A is defined as number is a multiple of 3. Event B is defined as uh, number is a prime number. So you know that the sample space of a die. Okay, let me change the color here. Just tell me who is it?
Venn diagram part around honestly.
Hmm. A or B. A or B means A union B, na? So A union B means either A or B, the total portion, right? Outer side, no. This total is a sample space, right? This S is representing the this you can see this rectangle is showing you the sample space, and this A and B are the subset of the sample space. So if they are asking only A unit A or B, or we can say they are saying occurrence of either A or B, then you will be saying only this portion. Of course, it is simple to it is similar to the set theory only, right? Here the sample space is acting as a universal set, you can say. Okay. Hmm. So here I said that in throwing a dice, what are the possibilities? 1, 2, 3, 4, 5, 6, as you already know. And then they are saying event A is defined as the number is a multiple of 3. If it is a multiple of 3, definitely 3 and 6 will come. And the event B is defined as the number is a prime number. So prime number, for the prime number you will be saying how many prime numbers in the throwing a dice you will be getting? 2, 3, and then 5, and that's it. Okay. 2 3 5 and sorry 2 2 comma 3 comma 5 only, right? So we were saying that either A or B, na? So let's write the A or B, or A union B. We can also say A union B. That will become nothing but 3 comma 6 union 2 comma 3 comma 5. You very well know from the set theory that can be written as 2 comma 3 comma 5 comma 6. Okay, is that clear? The only small difference is that in the set theory we were saying that A and B are set. Here we are saying that these are events, but the representation is same. Next, A and B, or we can say AB, or A intersection B, and that also says which represents the occurrence of A and B simultaneously. And if and is applied, means they are saying that both the sets are occurring simultaneously. With the same thing you can say sample space is there and the A and B are there, and this is the portion which is representing the A and B simultaneously, means the common portion between both of them, the common portion between both of them, right? There is example for this also. You can see in throwing a pair of dice, event A is defined as the sum of the number is 10. Okay, so there's a pair. Okay, one second. Yeah, so there is a pair of dice has been thrown. Okay, and event B is saying at least one number is 4. So there are two types of students who will solve this question. One of the student will write the whole sample space first, okay, and then he will choose the elements. However, will not go with that way. Okay, of course in the board exam you have to write in that way only. right? Like first write the sample space and then choose, like that. But if you are in the competitive exam, don't use that. Okay, how then what you will do, you know that if the dice 1 is there and dice 2 is there, on the dice 1 and on the dice 2 you need the sum 10. Okay, this is event A I'm talking about. You need the sum 10, right? So what can be the possibility? You just see carefully, you just see by yourself or think by yourself ki if I put 1 here, so there's another number on dice 2, is it possible that we get the sum as 10? If you even take the maximum possible number as 6, that will also not give you the 10. So the first possible number that you can take is 4, 4 comma 6, right? On the dice 1 we are getting 4, on the dice 2 we are getting 6. Similarly, then we can get 5 and 5, right? 5 and 5 is also possible, yes or no? Okay. Similarly, next is 6 comma 4. On the dice 1 6 is coming, and on the dice 2 4 is coming. All right. And then event B, at least one number is 4. At least one number is 4, you know that uh, in throwing a pair of dice at least one number is 4. But one more thing. Okay, we will see that. You can see here the pairs are pairs which are coming here 5 comma 5, 4 comma 6 and 6 comma 4. Similarly for the event B, event B is saying that at least one of the number from them is 4. So it means this can be taken, this also can be taken, but this is not possible because 4 is not coming. It is already said na ki at least one number should be 4. So therefore only two possibilities are there. Only two possibilities are there. Is it clear or no, everyone? Okay. So how do we represent that on the Venn diagram? Let me tell you. So the set A is having three pairs. Okay, but we will not represent here. We will just, okay, this has to be made little bit bigger so that you can see. I'm drawing here. So in this case, you will be writing the pair like this. 4 comma 6 will be here and 6 comma 4 will be here. That's it. That is the way of representation. Okay, and if you want to write the elements, so you will write A intersection B, A intersection B with the bracket, or you also can say A and B will be equal to the ordered pair 4 comma 6 and 6 comma 4. That is the way of representation for the elements. Both are the way, either Venn diagram, either this. Okay, both are correct. Let's go to the next. A but not B. It is clear. A should happen but B should not happen. That is A minus B. A minus B. That can also be represented as A intersection B complement. Right. A minus B means the portion which is occurring only in A. This is the portion which is occurring only in A, because this was the portion, common portion. This was the common portion. So this have to exclude, and only in A is called as A minus B or B minus A if you are saying B but not A. Okay. So it is saying occurrence of A but not B. Again we can take an example here. The example is saying choosing two cards out of 52 out of a deck of cards. Deck of cards, it is very well understood that they are saying 52 cards only. Event A is saying at least one card is ace. One card is ace. So let's say A can come, of course. Okay. Then it is saying event B, none is a face card. None is a face card. If none is a face card, it means uh, none is a face card means how many elements can come? You know that face cards are 12. So out of 12, remaining cards will be how much? Sorry, 3 4, yeah, 3 for the 12. Sorry, so face cards are 12. If you remove 12 from the 52, so total 40 cards you will be getting. remaining cards, right? Remaining cards which are not face cards. So total 40 cards you are getting. So it means none is a face card, means it is asking that those 40 cards, that can be anything including ace also. Similarly, at least one is a face card. At least one means minimum one face card should be there. Maximum it can be anything. Acha, how many maximum face card we can get out of two cards? How many maximum face cards we can get? The maximum we can get 12, but we are choosing only two cards, na? So maximum in this event we can get two only, yeah, right? So it is saying at least one face card. So one face as well as two face cards, they are saying. Okay. So I am writing, actually if you will write like that, so you will be getting A but not B. A but not B, or we can say A intersection B complement will be like this. So now you have to take the what? A but not B. A but not B. A intersection B complement means in these two you have to take the common portion, common part. So what could be the common part? So first is, you are saying at least one should be a ace card, so ace will be definitely there. Okay, and then you are saying the B event is at least one is a face card. At least, yes, tell me. Anyone is saying something? Do anyone wants anything to ask? Okay, okay. Someone has message, I guess. One ace card, one face card, correct. So one ace card, one face card. So A comma K, then A comma Q, then A comma J, right? Then the reverse can also happen, K comma A. Order is important, right? K comma Q and then K comma J. One second, one second, one second. Ace card is important now. One second. We have not taken into account. Yeah. So up to here it is fine. Up to here it is fine. A comma J, and then it will be K comma A, then Q comma A, and then J comma A. Now it is fine. Okay. So these are the answers. This is the answer, A but not B. Next. Okay, this question is done. Equally likely events. Equally likely events are those events which have same occurrence, same chances of occurrence. Means, one second, where it is? Equally likely events are those events in which you are having same chances of occurrence. Means, suppose that you are throwing a dice. So in that throwing a dice, you can say 1, 2, 3, 4, 5, 6 are the possibilities. And someone said that event A is defined as throwing an even number on die. For even number, you will be getting 2, 4, 6. And then B event is saying throwing an odd number on the die. Means 1, 3, 5. So you can see both the elements are having same chances of occurrence. Means this is also having the same element, same number of elements 3. This is also having the same number of elements 3. So both will be called as equally likely events. Okay. No, that is done already. Algebra of limits is done. Yeah, algebra of events is done. Next, mutually exclusive or disjoint events. Mutually exclusive means there is nothing common between the two events. That's it. That is the basic understanding of the mutually exclusive events. Disjoint events. Nothing common means the intersection part will be phi, or if you say the number of elements of A intersection B will be 0. Okay, we are studying only the basic terms. Later we will also solve some questions in which they will directly tell you that if these two events are mutually exclusive, then what is the probability of this? They can ask like this. So you have to understand these terms and remember, please, right? Next, so it is said that already by the definition, if you go, said to be mutually exclusive if the occurrence of one event rejects the possibility of occurrence of another. This is also the way, or you can say if there is nothing common or they are occurring independently, there is nothing common between them. So you can say this is A and this is B. Both are the subset of sample space, right? Both will be the part of the sample space, but there will be nothing common between them. Example is given, in a tossing a coin twice, two times means the two times you have tossed a coin, head occurs at least once. So first of all, let me write the sample space. This is the sample space you will be getting, H, right? Event A is saying head occurs at least once. At least once means, I told you at least mean minimum 1, maximum 2. Minimum 1, this is the possibility, this is the possibility, and this is the possibility. So 3 possibilities are there. So we can say the number of elements of event A will be 3. For the event B, tail occurs 2 times. Is it possible? Tail occurs 2 times. Yes, only one possibility. Okay, that means one possibility. So you can see there is nothing common between them, or you can say that the occurrence of these 3 events, or we can say the occurrence of these 3 elements is not, or we can say is uh, rejecting the possibility to come tail occurs, because if already these 3, suppose that of already head occurs, so then it is already rejecting the possibility of tail, na? So it is like that. Okay, this is like some sort of I told you in the starting also, this is like some these are happening independently, they are not having anything common. Okay, similar case will happen if you are increasing the number of events. Okay, if the number of events are increased, let's suppose you are saying A and B are mutually exclusive, so A intersection B was 5. Similarly, if number of events are increased, E1 E2 up to En, they will be called as mutually exclusive if and only if EI intersection E of J is 5 for all I and J that belongs to 1 comma 2 comma up to N, where I and J are not I and J are not equal. So it is basically told you because later on they can give you the 3 events also at a time, 4 events also at a time. So in that case you will write like this. So you can see A intersection B is 5, B intersection is C also 5, B intersection C is also 5. Then it is also given ki C intersection A is also 5. In that case you can conclude from here that A intersection B intersection C will also be equal to 5. Okay, but the vice versa is not true. Vice versa is not true, that you are saying ki if EI intersection EJ is 5, then this all the events will also give you the 5, or we can say no element common. Okay, so simple in the simple terms it is saying that if 3 events are given like this, ki there is nothing common between them, there is nothing common between them, or we can say A intersection B intersection is 5, it does not mean that the A intersection B is also 5. It does not mean that. You can see the example. Even though in all of the ABC there is nothing common between these two, you can see the common portion is negligible. Here it is negligible. Okay, but still A and B are having the common regions. B and C are having the common regions. A and C are also having the common regions. So it is just like that. Okay, next, exhaustive events. Exhaustive events. Yes, tell me. Yes, tell me. Okay, these actually these are the representation of different events in the inside the sample space. Okay, let's say if n number of events are happening, which will be represented in the sample space only, inside only, na? So this is the way of representation, you can say, inside the sample space, because n number of elements are happening, n number of events are happening, sorry. Okay, yeah. So exhaustive events, in the exhaustive events we say कि if E1 E2 up to En are the n events of a sample space, let's suppose, and the union portion, in this we are saying union portion, E1 union E2 union up to En, they all are giving you nothing but the sample space, then it will be called as exhaustive events. What do you mean? Means that suppose that 3 events are given, and for all those events you have written the possible outcomes. Okay, possible elements, whatever they are coming, and if you take the union of all these events, means of course they are set only, if you take union of all these events, and if they are equal to the sample space, then this will be called as exhaustive events. You can see in throwing a pair of dice, the first event is defined as prime number in a die. Prime number, 2 3 5 is possible, definitely. Event B is defined as throwing of an odd number in a die. Odd number means 135 only. Then event C is defined as throwing a number greater than or equal to 4. 4, 5, 6 is the possibility. Okay. But when you take the union part of A, union B, union C, you will see, you can see that it will be coming 1, 2, 3, 4, 5, 6, and that is also nothing but the sample space. So more or like you can say it is a sure event. You can say it is more or like sure event, right? Ki all the elements are consisting of, we can say, the total sample space. But here union will be used in the sure event. We can say for a particular event only. So event A, B, C, R, we can say they are exhaustive events. Mutually exclusive, nothing common. Exhaustive means if you take union of all of the events, it should come as equal to the sample space. Okay, this is the thing. Then this is the example given. Okay, this is the example given. You can see this. Okay, let's discuss this. The question is saying that card is drawn from a deck of 52 playing cards. The events are as follows. The card drawn is spade. C is given as card drawn is club. R is given as card drawn is red. Card drawn is king. And then D is given as card drawn is diamond. H is card drawn is heart. And B is card drawn is black. Then it is asking find whether the following set of events are equally likely, mutually exclusive, or exhaustive events. Acha, equally likely means same number of elements. Same number of elements. Okay. Mutually exclusive means nothing common. Exhaustive means if you take union of all of them, it should come as equal to the sample space. That's it. If you understand these three terms, a lot of questions are done. In this part, let's see. Okay, you already know these thing 52 cards. I already told you these are the total 52 cards, and 26 are black, 26 are red, and different things, different cards. Now let's discuss about the SDCH, whether it is equally likely or whether it is what was it, mutually exclusive, or whether it is exhaustive. So S means spade. Card drawn is spade. How many spade cards are there? 13 na? So 13 black cards we have considered already. 13 black cards we have considered already. That is spade. Then SD. D is where card drawn is diamond. Means 13 red card you have considered diamond, and spade is covered. Then the last third one is C. Card drawn is club. Means again 13 card is covered. 13 card black cards are covered. So till now 39 cards are done. Okay. Card drawn is heart. Card drawn is SDC. Yeah. Card drawn is heart means all the 4 suites of the 52 deck of cards are done. So can I say that this is mutually exclusive? Equally likely. We can say equally likely because each of the set will have same number of elements, or we can say same number of cards. Equally likely. Okay. Can anyone tell me whether they will be mutually exclusive or no? Mutually exclusive means nothing common. So nothing common means what? 13 black cards, 13 spade cards, 13 diamond cards, 13 black club cards, 13 red heart cards. Of course they all are totally different. Okay, they all are totally different, so this is also mutually exclusive. Mutually exclusive. The last one, exhaustive. Now the question is whether if you are taking the union of all of these parts, if you take union of all of these parts, will they give you the total sample space? Total sample space is what? 52 cards. Of course these are covering all the deck of cards, so this will be exhaustive also. Is this question clear, everyone? In this way we have to think about this. Yes, quickly tell me. If there is any doubt, you can also ask. Good. Next question is in the similar way. Will you try that if I give you? So next question is also in the similar way. You can try that. That is other 3 portion of this question. Okay, and let me know the answer in the next class. So take the screenshot. I am just sharing the question again one more time. Take the screenshot of this question and then you can try the other three portion by yourself. Okay, now I am going for the next topic, that is classical definition of probability. So now from here we will start with the probability. So it says that the number of outcomes favorable to event A means what, let's say we are saying that an event A has happened. So whatever the total number of outcomes, we'll be calling that as a favorable outcomes which we require actually. Okay, and if, and then of course we will be finding out the total sample space. So for that, total number of outcomes, total number of elements will be written as n of s. You can see n of s, that is nothing but we call it as a cardinality of A, cardinality of S. Remember, cardinality means number of elements. Then for probability of occurrence of event A will be written as number of favorable outcomes upon total number of outcomes. So number of favorable outcomes upon number of total outcomes means sample space. There is a note point here that this is what we are saying, probability of occurrence of event A. Okay, but what if someone is asking the probability of occurrence, non-occurrence of event A? So total probability of any, so you must remember this, that total probability can vary from 0 to 1 only. Okay, it can be either equal to 0 less or equal to 1, greater than 0, less than 1. Okay, this is the possibility. And so if it is asking the non-occurrence of an event, then simply they are asking the complement part, and complement part I already told you in the set theory or in the event, as I said, you have to subtract from the sample space. Okay, but when we are discussing the number of elements of sample space minus number of elements of set A. But this is the probability, this is the probability. So what you will say, for the probability you have to divide this by number of, sorry, total sample space total sample space. So divide that by total sample space, this will become 1 minus, this is nothing but probability of occurrence of A. So this is complement, sorry, P of A complement will be written as 1 minus probability of occurrence of A. This is clear? So 1 minus number of element of A upon number of element of sample space, you can also write like this, or 1 minus PA, simple. Alright, and the number of outcomes is saying that elements. So number of outcomes of A, C, or we can say complement of A will be written as number of sample space, number of elements of sample space minus number of elements of set or event A. Now based on this is the last question of today's session. Okay, you can tell me the quickly if you know the answer. A leap year is selected. Leap year means how many days? Exactly. So total 366 days. Find the probability that it has 53 Sundays, 53 Mondays, and 53 Sundays and Mondays, and then 53 Sunday or 53 Mondays. So can anyone tell me the first answer quickly? Okay. What about the second one? First one is 1 by 7. What is the second answer? All right. Zero. How many odd days are there? No, two extra days are there. You have been confused. 360. Hmm. But is it? But is this 365 is divisible by 7? Got the point or no? Let me tell you. So this will be covered 364 days plus 2 days extra. Why I am writing like this? Because this directly covers 52 weeks. 52 weeks means 52 into 7. Why this is 52 into 7? Because 7 weeks consist of, sorry, 1 weeks consist of 7 days. So it is good if we convert them into the weeks. Why it is there? Because we say that generally we consider that Sunday is counted as like the first day, and then Monday, then Tuesday, and like that. Okay, so the rest of the 2 days, what is the possibilities? Rest of the 2 days, the pairing will be done. The pairing will be done like this. Either it can be Sunday, Monday. Okay. Either it can be Monday, Tuesday. Okay. This is the possibility of 2 extra days. Then either it can be Tuesday, comma Wednesday, or either it can be a Wednesday, comma Thursday, or either it can be a Thursday, comma Friday, or either it can be a Friday, comma Saturday, or either it can be a Saturday, comma Sunday. Okay. So these are the possibilities for the 2 extra days. Now the first question is asking that 53 Sundays. So for 53 Sundays, just count the Sunday only. In the first, here you can get one Sunday, here you can get one Sunday. Out of the 14 days, these are total 14 days. Okay, so 2 by 14, sorry. For the 1 week consists of 7 days, right? So we'll say that 2 out of 7. So first answer. One second, have we done some mistake? 2 by 7 is the first answer, right? Not 1 by 7. Yes. So 2 by 7 will be the first answer, because 2 Sundays are possible, not 1 by 7, right? 2 Sundays are possible, so 2 by 7 is the answer. What about the second one? See, there is a role. They are saying and here. There is a role of this and. You must understand. And they are saying that if they are saying and, it means uh, they should be consecutively. They should be consecutively. Means Sunday and Monday should occur consecutively. So 53rd Sunday and Monday can occur only one time. Occur only one time. So that's why only 1 out of 7 is the possibility. Is that clear? Okay. Then there is a role of this or also. They're saying 53 Sundays or 53 Mondays. Now you have to consider separately, individually, that Sundays. How many Sundays are there? One Sunday, second Sunday. So 2 Sundays are possible separately, right? Then how many Mondays are possible? One Monday and yes, second Monday. So 2 Mondays are also possible. So in total, 4 days are possible. So the probability will become how much? 4 by 7. Sorry, 4 by, yeah, just a second. Sorry, three. No, three is the answer. Yeah, correct. So one Sunday and Monday is already coming. Yeah, correct. You are saying correctly. I got mistaken. One Sunday and one Monday is coming already. So you have to count Monday and Sunday only. That is coming separately. So one Sunday is there here, one Monday is there here. So then plus two. So that means 2 plus 1 or 1 plus 2. You can say. So total 3 events are there here. So this will be the answer 3 by 7. Okay. Hmm. For the previous case, they are saying and na. So if the and is there, they are asking consecutively it should come. Means if it is the first day is Sunday, second day should be Monday, like this. With formula, this is the way. That will be a little bit longer method. That's okay. For with formula also you can find out, but that will be a little bit longer method. Rather, I say that just consider the odd days. Okay, this is the simplest method. Odd days and go for it. Or 53 Mondays or 53 Fridays. What is the possibility for this? Means you have to consider separately now. So how many Mondays are separately there? One Monday is there. One Monday is there. 2 Mondays are there. Check whether Monday and Friday are occurring together. There is no possibility, you can see. Okay. So then check for the Fridays. This is the one Friday. This is the one Friday. So 2 Fridays are also there. So in total 4 days here. That is our favorable outcome. You can see these are favorable outcomes we are finding out. And what are the total number of outcomes? 7 only. So we are saying that 4 by 7, this will be our answer for the last one. Okay, I hope that this question is clear. If you have any doubt, you can ask me. So these are the answers I have given: 2 by 7, 1 by 7, and 3 by 7, and lastly 4 by 7. If they ask for 52 Sundays, then for 52 Sundays, it will be, of course, because 52 Sundays are already occurring. Okay, for 52 Sundays they are already occurring. So one more Sunday is, so how many extra Sundays are there in this leap year? They are asking this one. So you can say, okay. So with this, now we have reached to the end. Hope you all enjoyed it, and now we can discuss if you want anything. So hope you all enjoyed it. Thank you.